Here we go. Average value of a function. If I want to find the average value of this function, what would you do? Integrate from 0 to 4. Integrate from 0 to 4 of this function. All right, that. Okay.
And what's your like actual GPA comparison?
Like without bonus of 3.9.
Awesome.
Well, it's because I have an F because I'm missing. I wish I figured it out.
Are they like when you turn in all your work and you get like an A in the class but an F in the weekly post?
Yes, and then the sets are right next to each other, or like right after, like yeah, or it's just like you're gone for one day and then like, your grades just flood in.
Okay. So looking at this, if we go math 9, it brings up the integral 0 to 4 of x cubed, and then times the square root of x squared plus 2x plus 1 dx. If we do that, we get 268.8. Well, 268.8 is the total amount, not the average. So we have to divide by, and then we subtract those. 4 minus 0 is 4. So if we divide that by 4, the average value of the function is 67.2. Okay? Average value. All right. The next one. This one's a little bit of a humdinger. Okay? That's not at. The acceleration of t is negative 2t at time equals 0. The velocity is 20 meters per second, and the position is 18 meters. What is the position at 2 seconds? Okay? Well, if we're given acceleration, what do we have to do to get back to position? We have to integrate it to get to velocity, and then integrate that to get back to position. So if we integrate this, if we integrate negative 2t, we get negative t squared, right? Plus c. Well, at time equals 0, what's the velocity? 20 meters per second. So when t equals 0, c must equal 20, right? So my velocity function equals negative t squared plus 20. Are we good with that?
Yeah.
Okay. I'm going to change this, make it a little bit fatter. Do it there. Okay. So then we're going to integrate negative t squared plus 20. And what are we going to get? 1/3 t cubed plus 20t plus c. But at time equals 0, what's the position? 18. So we got to throw that 18 in right now, because that happens at time equals 0. So if we put zeros in here and we set that equal, we don't have to do all that math. You just know that that's 18, right? For C? When time equals 0, C is this.
Yeah, okay.
If we plug in 0 for the t's. Okay. So if we have that, what's the position at 2 seconds? We just throw the 2 in there. So negative 1/3 times 2 cubed plus 20 times 2 plus 18 equals 55.55 and 1/3 is the position. Okay, are we good there?
Yes.
So we got to integrate a couple times there. What's the total distance traveled in this velocity versus time graph? What do you think, Ashley?
Total distance traveled?
Yeah.
6.
No.
That's what I would guess.
What we do is I would break this apart.
And you just count the little boxes.
Count the little boxes. There's 1, 2, 3, 4, 5, 6, 7. And then these two add to 1. And then you got a 0.5. So as you said, Ashlyn, 8.5. Oil leaking from a tank at a rate of R sub T equals 6 minus the square root of T gallons per hour. How much oil leaked from the tank from time equals 0 to time equals 9 hours? What do you think we do here? Integrate, because you're finding an amount. Integrate from 0 to 9 of 6 minus the square root of T. Okay, so math 9. Isn't it so nice that I showed you this little button?
Yes. Get a better calculator.
Wait, you're probably doing this?
No, you can do
You've been
that by
doing it
hand.
all by hand. I just graphed them.
Which still gets you the same place. And since there's so many 9s, this equals 36. Okay. And the great thing about this test, it is multiple choice. The area of the region enclosed by these two graphs is what? What should you do? Oh, geez, graph them? Really? Okay, graph them. And then x squared minus 4 looks like this. So you're going to have this area, okay? So under y equals, we'll clear out those two. So under y equals, it's 1/2 x. And then the other one is x squared minus 4. And which one should I have on top? Yeah, it does matter. Is the 1/2 x on top or the x squared minus 4 on top? The straight line, which is 1/2 x. So it should be y2 minus y, or y1 minus y2 when I do this. So I won't even graph those two. I'll just go straight to y1 minus y2. I'll graph that. It'll make a little parabola. Then I'll go second trace, 7. Second trace, number 7. The lower limit. Ooh, where do these intersect? Well, you set 1/2 x equal to x squared minus 4. Oh, that's not going to be very nice, is it? What am I going to, what should I do?
Go back and grab the past two.
No.
What do you mean no?
I could find the 0 of this function. Yes, Miles, you could go, but yes, Miles, you are correct. You could go back and graph the last two and figure out where they intersect. Or you could just go straight to here and figure out where it crosses the x-axis. This crosses at negative 1.7656. And then on this side, second trace, 0. Find the 0 of the function. Oh, I hate when it does that. Enter. Go past it. Hit enter and enter again. And 2.2656. And then second trace 7, you're going to go from negative 1.7656 to 2.2656. Boom. Fill it in, and it's going to be 10.92. We good with that?
Yeah.
Just got to figure out the intersections. And yes, we sure could have done it Miles's way, which is a totally proper way of doing it. Okay, find the area of the region enclosed by these two graphs, and we know that they cross at an x value of 1 and an x value of 4. Okay, so I'll just do it, and I'll just graph them first without this extra thing graphing, and then we can talk about it. So we have x squared plus 3x plus 5, and then 4 minus 2x minus x squared. And if we graph them, ooh, they don't cross at 1, 4. Did I throw something in there wrong? Nope, that's what it is. So I'm going to have to find out where they cross. So I'll use Miles's method. Second trace, intersect 5, go to close to on this side, and go enter, enter, enter. They intersect at negative 2.28. And then second trace, intersect. They intersect at negative 0.22. And then second, we want to go y equals. Turn off these two. What's my top curve? Y2 or Y1 in this case? Y2 is my top curve, so I want to use this one. So second trace 7, let it graph. And then, what? And then go negative 2.28 to negative 0.22. It'll fill it in and give me 2.92. Okay? Okay. This one, not even looking for a numerical answer. Find the integrals of the area enclosed by the functions. So how would we do this? So you'd integrate from where to where? 1 to 5 would be what minus what? G of x minus f of x dx plus the integral from 5 to 9 of
F of x minus g of x.
y.
Because the rectangle's on top now.
Yeah, top minus bottom. All right, now we get to the fun ones. Yes, that's all we needed to do. I said we weren't looking for a numerical answer. No, it was that simple. Yep. A solid in the first quadrant is bounded by both the x and y axis and y equals 4 minus x. So let me kind of draw that out. 4 minus x would be 0, 4, and 4, 0. Wow, did I miss? There we go. All right. And it's bounded by the x and y axis, so it's this in here. What is the volume of the solid if each cross-section is perpendicular to the x-axis and it's a square? So the little rectangles are perpendicular to the x-axis. Okay? What's the height of each square? 4 minus x. Okay? It goes this way, and then when you go three-dimensionally, since it's a square, it's also 4 minus x, correct? So if it's 4 minus x times 4 minus x, it's 4 minus x squared for the square. It goes from where to where? Where's this? 0 to 4. 0 to 4 dx. So then, math 9. From 0 to 4 of 4 minus x squared. I might have to put in another parentheses here to make it work. Dx.
Oh, what did you do to do that?
What do you mean?
I mean, how did you like not have to erase the 4 to do that?
I do second and delete, which is insert.
That is good to know. Okay.
Okay.
Oh.
Second delete is insert, so you can just.
Because I've always
flip.
just like had to like rewrite everything.
Oh. Second delete is insert. Yeah. All right. So then if we go math, change it to a fraction, please. It's 64 pi. Or it's 64 over 3. Not 64 pi. There's no pi because there's no circles involved. 64 thirds. Okay? Okay. The next one will involve pi, I bet. Yep. Same thing. Same drawing. Except for this time, we're doing semicircles. What's the area of a semicircle?
1/8 r squared.
1/2 pi r squared. Yep, 1/2 pi r squared. Now, the radius of this semicircle is not this whole distance. It's half the distance. So, your 1/2 pi and then your r squared, your r is going to be 1/2 of 4 minus x squared. And I think we should go like that.
So then it goes to 1/4. So that's why it's 1/8.
Actually, that's why it goes to 1/8. Because you're squaring the 1/2, basically, and times 1/2. So I'm going to enter it into my calculator like this. So math 9, and then we're going to go from 0 to 4. And then I'm going to go up front. Can I go up front and go second insert? 1/2, and then pi in front. There we go. And then I'm going to insert an extra parenthesis and go 1/2, so 0.5 times 4 minus x parenthesis squared, not -1, 2, delete. And then that's dx, and enter. Oh, take out the pi, Mr. Bierschbach.
No way. No pie. No pie.
No pi for you. Delete that. Enter. There we go. Math, change it to a fraction, please. 8 pi over 3. There we go.
That just looks so much easier than what I swear it feels like.
All right. Region bounded by the x and on y axis. Horizontal line y equals 2. And the graph of y equals x minus 2, the square root of x minus 2. So if y equals the square root of x minus 2, that's 0 would be at -2. So if we're at 2, we're at 0, right? 2 gives me 0. 3 gives me 1. Yeah, 3 minus 2 is 1. The square root of 1 is 1. So 6 gives me 2. So at 6, it gives me 2. So I'm kind of going up like that. I've got y equals 2 here. I'm also bounded by the x-axis and y-axis. So this is my region right here that I'm going with. Okay? Because anything to the left of 2 doesn't work. So what's the volume if it's revolved around the y-axis? So if we're going around the vertical axis, what do I have to do with this? Solve it for x. So if y equals the square root of x minus 2, I square both sides, so y squared equals x minus 2. So y squared plus 2 equals x. That's this line. Okay? Since it's flush up against the y-axis, it's not the washer method. It's the disk method. So it's just pi r squared. So my radius is y plus 2, y squared plus 2 squared. I'm going from where to where on this one? Is it 0 to 6 or 0 to 2 for my integral? 0 to 2 because I'm working along my y-axis. 0 to 2. So then I just plug that in. Second, no, not second, math, 9, and then 0 to 2 of x squared plus 2 squared dx. And then I go math, change it into fraction, please. Oh, yes. 376 pi over 15. All right, volume of a solid generated when a region in the first quadrant is bounded by y equals 4x, the x-axis, and the vertical line x equals 6 revolved around the x-axis. So y equals 4x is a fairly vertical line like this. X-axis, vertical line at x equals 6 is like this. And we're revolving around the x-axis. Washer disk method. It's solid against the x-axis. It's the disk method. So it's pi integral. What's my top line? What's my top line? Y equals 4x, right? Well, it's the line above where I'm revolving around. So it's just the 4x. There's only one line that I'm dealing with. So it's 4x. How far am I going from where to where? 6, because it goes, here's 0, here's 6. It's going up like that. So pi r squared. Uh-oh. I'm going to have to go back and teach from back here. All right. Come back. Of course you didn't come back, right? No. All right. So if we do that, we go math number 9 from 0 to 6 of parentheses 4x squared dx graph. Why am I graphing? Enter. So it's 1152 pi. Rather large. Because if we go over 6, we're like 24 up. And so, yeah, makes a pretty good sized radius there. All right, next. We have a region bound by the graph of y equals 2x. Y equals 2x. Horizontal line y equals 4. And the y-axis. And we're revolving around the horizontal line of y equals 4. So we're revolving around this line. Okay? Wash or disk method? Still the disk method because we're solid up until the line that we're revolving around. So it's pi r squared. Now, this line is what I'm working with. So 2x is what I'm working with. So it's 2x squared. But I'm around 4. So it would be 4 minus 2x squared. Because this distance from 4 to 0 would be 4. This distance at 1, because this is a point 1, 2. So that distance should be 2. 4 minus 1. 4 minus 2 is 2. And at 2, this would be the 0.24. So 4 minus that is 0, which makes sense. So it's 4 minus 2x squared. Top curve minus the bottom curve. Okay? And then we go from where to where? 0 to 4 or 0 to 2? We're revolving around the line y equals 4. So it'd be 0 to 4 or 0 to 2? 0 to 2, because it's my x that I'm measuring across. Okay? So, math 9 from 0 to 2 of 4 minus 2x. Oops. Need to insert a parenthesis squared dx. Enter. Math, change it into a fraction, please. So 32 pi over 3. All right. This one. So we have y equals x. So it goes like that. Y equals x squared. So it goes like this. From 0 to 1, because they meet at 1, 1, is where these two intersect at. What's the volume of the solid generated about the line y equals 4? Y equals 4 is up here. Disk or washer method? Washer, because there's place in between. So for this one, this is a little tricky, okay? Because you have to go 4 minus this line minus 4 minus this line. So it's going to be 4 minus the bottom line, the further away line. So 4 minus x squared